So first of all, just to put kind of the recent climate change into some historical context, we're going to just have a quick look at what the climate's been like to recap what the climate's been like over the past 1,000 years or so. And this, you can't read all of this, it doesn't really matter, but they're basically a whole bunch of different evidences we have for what the climate's been like in the past. But once we go past the instrumental record, once we get past kind of 100 years ago, we have to use proxies. So ice cores, corals, tree rings, things like that. Okay? And that's what is plotted up in this graph here. So now we've got this is kind of now, 21st century, going back 2,000 years into kind of the past. And what we've got here is a whole bunch of series of different proxy reconstructions of temperature. Okay? And the top graph is trying to reconstruct the average northern hemisphere temperature. This graph down here is the average southern hemisphere temperature. Okay? And this is an attempt at reconstructing the global temperature. Okay? And you can see that not all of the proxy records agree, okay, because they're not direct measurements of the global average temperature. Okay? They're a proxy measurement of some kind of maybe local temperature. So if you're maybe measuring tree rings, you're measuring maybe a combination of temperature and precipitation where that tree grew. And you might build up a regional kind of view of measuring lots and lots of trees. And that might be slightly different to measuring it in a different region or using a slightly different proxy, which is why we have so much scatter, okay, in these data. Okay? But the overall picture is that even if you look at all of the noise in the data over here, okay, this kind of warming at the end here, and the black line is the instrumental temperature record, okay, that is kind of unprecedented in the last 2,000 years. Okay, so we're warmer now than we ever have been. Okay, and this is just kind of like just looking at that instrumental record, just to give you an overview of where some of the data comes from. So these three images of the globe are all the same data set. Okay, so the top data set is the Hadley Centre Climate Research Unit data set for extrapolating global temperatures. This is where we actually have measurements. And what that group does is they just take all of the actual measurements and they say, we're just going to average those. So obviously if there were, and these are the differences in basically the long-term trend, so the amount of warming we've had since 1900 to 2012. Okay, so you can see most of the globe has warmed. There's a small patch of the North Atlantic which is not warmed, which is kind of interesting. But all they do is they average up all of the measurements. Okay? So that obviously has a little bit of a weakness in that there are some parts of the world that in 1901 no one was measuring the temperature. Okay? So in Africa, no one was measuring the temperature. Some people measure it in South Africa and kind of Kenya and kind of in Egypt, but lots and lots of not measurements. So if there was dramatic climate change that was unusual compared to the rest of the world in Africa or in South America or in the Pacific Ocean, that wouldn't be included in the data set. Okay? And these basically is just two other research groups that basically have different ways of trying to extrapolate across these gaps of data. Okay? The important point is that when you do that, so these are basically, and we went through this yesterday, all those different approaches of kind of like different ways of averaging the data, it doesn't matter. Okay, so even though the raw data has got lots of kind of holes in it, okay, it doesn't make any difference really as to how you average it up. We still get this kind of really robust trend of warming over the last century. Okay, so what we do to try and figure out why that warming has happened is, so this graph is kind of slightly complex to understand. So the first thing to note out is that this grey splodge at the bottom, okay, is that climate proxy data. So it's basically averaged together all of those curves that were really, really noisy, and that says that's what the climate is doing. So you can see it's kind of constant, maybe cooling down a little bit towards the 1600s, and then warming. Okay, but there's quite a lot of error in that. Okay, and then what this experiment has done is it's taken climate forcings. Okay, so it's taken the climate forcings which we talked about kind of yesterday, which were up here in this diagram up here. So you can see with the top graph is the forcing due to volcanic eruptions, Okay, so usually there's no forcing unless there's an actual eruption, and then there's a cooling forcing. So you can see these are negative radiative forcings. Okay, and then at the bottom here we've got another axis. This is the radiative forcing from carbon dioxide mostly, or anthropogenic greenhouse gases. Okay, and you can see that's not happened. Nothing's really happened with that over the last 2,000 years, and then industrial revolution kicked off, and we got this large increase in forcing here. And then the ones in the middle here, these are the changes in the solar flux due to those changes in sunspots, and you can see two different kind of like modes of variability in that. There's the blue line and the pink line. It's kind of browny orange, but anyway, whatever. So that's relatively small. If you just look at the scale here, that's been expanded out compared to the other two. Okay, so this is a relatively small effect. Okay, so, and what kind of the researchers have done here is they ran a whole series of different climate models using those forcings. And they ran two groups of climate models. They ran a series of climate models that only had the natural forcings. Okay, so they only had volcanic emissions and changes in the solar kind of flux. And they ran another group of models that had all three, so included the greenhouse gas changes from anthropogenic emissions. Okay, and that's what the coloured lines are at the bottom here. Okay, and you can see that kind of throughout all of history, all of the history of this graph here, over the last 1,000 years here, all of the models kind of agree with the splodgy data behind. Okay, so it doesn't matter if you include the greenhouse forces or not, we match them. Okay. And the models with the greenhouse gases are the ones with the thick lines, and the models without greenhouse gases are the thin lines. So you can see that it's all good across time until you get to about here, and then the two sets of models start to diverge. Okay, and the models that don't include carbon dioxide greenhouse gas warming start to not explain the data very well. Okay, so this is a line of evidence that says to explain the temperature record, you need to have a model that includes a CO2 rise over the last 150 years. Okay. Put that in. Oh, so this is the basically the where that warming, where that radiative greenhouse gas forcing is coming from. So you can see we've got most of it is from carbon dioxide. Okay. Some of it is from methane. And importantly, so methane doesn't hang around in the atmosphere very long. It does convert into, it oxidizes into CO2 and water. And you can see that those then have a secondary effect. So they, even though you get rid of the methane, you still have this effect from its kind of breakdown products in the atmosphere. So it doesn't completely go away. Similarly with kind of CFCs. And then you have this effect of aerosols, which we went over. So this is like volcanoes going off, but emitted by man. Or people, should we say. People. It's mostly men. So this is another plot of that graph of comparing the model outputs with the climate data. Okay, so this is basically a close-up view of the last 150 years, and the red line are basically all of those different ways of reconstructing global temperature. Okay, so that's what global temperature is doing, and then a bunch of models have been run, okay, with just the natural forcings or just the anthropogenic forcings, and in this case they've got the natural forcings, all forcings, and then just the anthropogenic forcings. And you can see that if you just use natural forcings, the model, which is the grey line here, does okay at explaining the data, not great, and then really doesn't explain the last 40 years or so at all. If you just use anthropogenic forcings and you ignore all the natural variability, you do quite well. You do better than the natural forcings, so these match a little bit better, but there are still bits where it doesn't match. Okay? Whereas if you apply all of the forcings, if you basically put everything you know has happened into the model, you obviously do a lot better. Okay? So to explain the recent warming, you need natural forcings and anthropogenic forcings, but you cannot reconstruct it without the anthropogenic forcings. Okay, so we can go onto a little a level of more detail, and so rather looking at the global average, we can then look at kind of regional changes. Okay, so we can look across different regions of the Earth where we have temperature records that have that we record the temperature through time, and kind of that's what the black curves in each of these plots represents. Okay, and then we can do two sets of models. We can run climate models that only have natural forcings, and then we can also run them that have natural and anthropogenic forcings. So the natural are the blue lines, and in some places it doesn't really matter. So if you look at the sea ice cover in Antarctica, down here at the bottom, it doesn't matter. Our models are not really very sensitive to having anthropogenic forcing. Okay? And that's kind of because there's not really much change going on in Antarctic sea ice at the moment. Okay? But if you look at the Arctic sea ice, right. If you look at the Arctic sea ice at the top there, you can see that the Arctic sea ice, the black line is descending rapidly. Descending rapidly down here, okay? And the red line follows it, so the anthropogenic forced models do reconstruct that, but the natural models do not. And in almost all regions, okay, the recent climate change, you need the anthropogenic emissions to explain what's going on. I think it's this. Anyway.